Hey, hi. Let's wait for a few more minutes for this. Okay, let's start. Are you guys able to hear me? Omkar, can you hear me? You are on mute if you are saying anything. Hello. Hey, am I audible? Hello.
Yes, sir. Yes.
Okay, okay. Yeah, let's start. Let me share my screen. So today we are going to do the recursion and backtracking. Have you done the question from the previous session? Have you done the session on the previous questions? I mean, like for example, previously we did the linked list, we did the sliding window, we did the two-pointer approach. Have you done the question on that? Okay, seems no. No issue. So today we are going to start a fresh topic, which is recursion and backtracking. It's not related to any of the previous topic which we have discussed yet. So it will be a kind of a fresh topic. So let's start with that. Just give me a second. Let me plug the fan tab first. And my screen is visible to you or not? Please say yes and no. I may not be able to see the chat every time.
Yes, sir.
Okay, great. Yeah, let me just plug this. One second. Okay, so today we are going to discuss which is yeah, okay, recursion and backtracking. So if I so you guys remember the question which we did for two sum, so that we are given an array which is 1, 2, 3, 4, 5, 6, 7, 8. There was a question which we did was two sum, that you need to find out a pair whose sum is equivalent to the given target. And what we were doing to solve that question by using brute force approach, we were using two loops. We were using two loops to solve that question with a brute force approach. Now, if I ask you to find the three sum, basically find a triplet whose sum is equivalent to the given target. What we were using there, what we will use there, it will be three loops, which is again a brute force approach. And similarly, if someone asks you to find a sequence or to find a fourthlet, I mean to find a, pair in such a way that there will be four values and whose sum is equivalent to the given target. So in two sum, you find a pair which is x and y to say if their sum is equivalent to the given target or not. In three sum, you find three values whose sum is equivalent to the given target, and in the four sum, you will try to find the four values whose sum is equivalent to the given target. And for this one, how many loops you will use? Four loops. Now you can see this is clearly a no end for you. Okay, for example, for tomorrow, if someone says five sum, then you will again use five loops. Is there any better way to do these questions? Or if I ask you to find any kind of subarray, sorry, to find any kind of subsequence whose sum is equal to the given target. It can be one sum, two sum, three sum, four sum, five sum, six sum, seven sum, but their sum should be equivalent to the given target. So how we can find that? Even if you tell me what can be the brute force approach to find that? Because right now what we are doing is that what we are doing is for two sum we are using two loops. For three sum, we are using three loops. For four sum, we are using four loops. But now, if you want to find out all kind of pairs, it can be two sum, it can be three sum, it can be four sum, but their sum should be equivalent to the given target. How we can find that thing? I just want a subsequence whose sum is equivalent to the given target. Can anyone tell me how we can find that? Any idea? No. Okay. Let's first discuss how these two loops, three loops actually works basically. If we think about the two sum problem, we were writing the code something like this. For I will just like miss few of the keywords just to focus on the main thing. And I plus plus. Was our code. And inside that we have another for loop, which is j equivalent to g should be less than n, j is increment. Now how these two loops are actually working. So let's say the given array is something like this. 1, 2, 3, 4, 5. Now let's try to visualize this code run. What will happen is first this for loop will start iterating from this one. Let's say the code is here something like this: array I plus array j. So it will say, hey, with one, let's try two, then let's try three, then let's try four, then let's try five. Okay, now we are done. Now again, this thing will happen. Now with two, it will start. Hey, with two, let's try to use three. Let's try to use four. Let's try to use five. Now again, this will happen with three. Hey, let's try to use four with the three. And then let's try to use five with this. And then again with the four. This way. This first loop is showing these first values. This, then this, then this, and you can say five, but there
However,
is no more pair to create it. Yeah.
it's not visible.
What is
Hello,
not visible?
coding screen.
Okay. Okay. Let me reshare it again. Is it visible now?
No, sir.
So you are not able to see the draw pad like whiteboard.
Yes,
Or why? Because okay. Now
no, sir.
Were you able to see it initially? Were you able to see it initially when we started the session?
Yes, sir.
Okay. I don't know what happened. Let me try to rejoin in that case. Okay, let me try to reshare the screen now. Hopefully this should work. Can you see this?
No, sir. Yes.
No.
Yes, yes.
Okay,
Not
wait.
visible.
Visible or not visible?
Visible. Visible.
Can you type in the text? Okay. Yeah. So I was saying, let's say we are given a two-sum problem and we are given this array 1, 2, 3, 4, 5. In the right, I have written the code for two for loops by which we are solving this brute force problem. Like we are solving this two-sum problem by using the brute force approach. Now these figures which I have drawn, this 1, 2, and 3, these ones. Just yes, this one, these ones. This one, this one, this one, this one, this one, and this one. This is showing how this code is getting executed actually. So this first for loop is helping us to generate these numbers 1, 2, 3, 4, and then 5. And this second loop is generating the second level of this tree, which is this one. So with 1, first we try to form it with 2, 1 and 2. Try to form the 1 and 3. Then we form the 1 and 4. Then we try to form the 1 and 5. Similarly, then we do it with the 2, 2 comma 3, 2 comma 4, comma 5. Then we try to do it with 3, 3 comma 4, 3 comma 5. Then we try to do it with 4. And then with 5, we don't have any more there. What I'm trying to explain you is recursion is actually working. How we are going to solve the problem if someone asks you to find the all the pairs, to find all the subsequence where the sum is equivalent to the given target. When we say subsequence, it can be 2 values, it can be 3 values, it can be 4 values, it can be 5 values. If I go up, I'm not sure whether you were able to see the previous one. Here I have mentioned that if we try to solve two sum problem where we need to find a pair whose sum is equivalent to the given target, then we use two loops. If we go with the brute force, and if we need to find out triplets, a triplet means like three values in such a way that their sum is equivalent to the given target, then we need three loops. Similarly, for four sum, it's four loop. Then how we are going to solve this problem of uh, finding those subsequence whose sum is equivalent to the given target? Because subsequence can involve two sum also, three sum also, four sum also, five sum also. After that, I was showing that how this two sum code is actually working, how this tree is actually looking like. Similarly, if we talk about three sum problem, so how the three sum will work? If we generate the tree for that, let's say this is the array. Okay, so first we will start with one, then one will try to form the pair with two, two with three. Then we will do this also. Then we will do this also. Here, three can form with five also, can form with this also. Then one can also again start from what? 4. Then it can be this also. Are you getting these things like how I'm generating this? If we need to find out all the triplets, this is how you will find out. So one of the triplet can be this, which you will generate actually. Check if this is equivalent to the given target. Let's say target is 5. No, this is not. Another pair would be 1, 2, and 4. Is this another, like if we add it up, is it equal to given target? No. Then 1, 2, and 5. 5 plus 2 plus 1, which is what? 8. It's not again equivalent to the target. Then 1 plus 3 plus 4. Have we found out the target? No. So this is how that three loop is generating the pairs actually. There will be one more thing here, which is now. So now let's say in triplets the values are A, comma B, comma C. When we are generating the combinations, we are saying hey कि यार हम सारी वैल्यू ट्राई करेंगे एबीसी के लिए. तो हमने पहले ए पे क्या किया, हमने ए पे 1 सेट कर दिया, फिर हमने बी पे 2 सेट कर दिया, और अब हम सी पे जितनी भी बाकी इसकी वैल्यू है वो ट्राई करने वाले हैं. इट विल बी 3, इट विल बी 4, इट विल बी 5. अब हमने क्या किया, वन और वन को ऐसे ही रखा. अब 2 के साथ हमने सारे जितने भी पेयर्स फॉर्म हो सकते थे तो हमने बना लिया. अब हमने बी की वैल्यू दोबारा चेंज की. बी की वैल्यू हम रख सकते हैं क्या, 3. अब यहाँ पे वैल्यू क्या क्या हो सकती है सी पे, इट कैन बी 4 और इट कैन बी 5. अब ऐसे दोबारा से कर सकते हैं. So this is how we are generating the pairs. Is it clear like how we are generating these pairs? How this two loop is working, how the three loops are working, how they are actually working visually. Is it clear?
Yes.
Yes. Okay. Now, now we need to now let's do a question basically. We are given an array which is 1, 2, 3, and 4. Let's keep it short. And the target is let's say 4. Let's say 5. I mean. We need to find out all the subsequence whose given is whose target is equivalent to whose sum is equivalent to the given target. Find all Do everyone know what is sequence? Yes or no? Do you guys know what is subsequence or not? What is sequence and subsequence? I have covered it in the last session also. Okay. So subsequence one or can be one, two, three, four, 1, 2, 1, 3, 1, 3, 2, 4 और इससे कि यार चलो अगर सबके को भी हटा देते हैं हमको जिसका जो सम है वो टारगेट के इक्विवेलेंट होगा मतलब वो 5 के इक्विवेलेंट होगा। अब हम वो कुछ भी बना सकते हैं 1 1 + 2 1 + 2 + 3 1 + 2 + 3 2 + 4 2 + 3 + 4 कुछ भी करके हमको वो सारे कॉम्बिनेशन निकालने हैं जिनका टारगेट 5 के इक्विवेलेंट हो। अब वो हम कैसे निकालेंगे? अगर मैं अब इसके लिए एक ट्री बनाता हूँ तो कैसे होगा? सपोज करो हम पहले 1 से स्टार्ट करेंगे। हम बोलेंगे यार 1 के साथ ना 2 की वैल्यू ले लेते हैं और 2 के साथ 3 की वैल्यू ले लेते हैं और 3 के साथ 4 की वैल्यू ले लेते हैं। हम ऐसा करते हैं सबको ऐड करके देख लेते हैं क्या टारगेट के इक्वल आ रहा है नहीं आ रहा है। चलो कोई दिक्कत नहीं। अब हम क्या करते हैं 1 2 3 क्या 3 के साथ जब हम 3 और 4 को कर रहे हैं क्या इसके अलावा और कोई वैल्यू है जो हम यूज करके सम बना सकते हैं? वो नहीं है अभी के लिए। ठीक है, तो हम पीछे आ जाएंगे। अब चेक करते हैं यहाँ पे क्या हम यहाँ पे 3 की जगह कोई और वैल्यू यूज कर सकते हैं? हाँ कर सकते हैं। हम ये ट्राई कर सकते हैं 4। क्या 1 2 4 सम के इक्वल है? जो टारगेट हमको चाहिए उसके इक्वल है? नहीं है इक्वल। तो हमारा ये पेयर भी नहीं बना। अब हम दोबारा से पीछे आ जाते हैं। क्या हम 1 को 3 के साथ रख के पेयर बना सकते हैं? 1 3 4 बना सकते हैं। आर यू गेटिंग इट लाइक व्हाट वी आर ट्राइंग टू डू? हम सारे के सारे कॉम्बिनेशन बना के देख रहे हैं। पहले 1 से स्टार्ट किया, फिर देखा यार 1 को 2 के साथ रख के देखते हैं, 1 को 3 के साथ रख के देखते हैं, 1 को 4 के साथ रख के देखते हैं। हमने इस 1 को 2 के साथ रखा, 3 के साथ रखा, 4 के साथ रखा। तो ये हमारा बन गया 2 सम। अब हमें अगर हमें 3 सम ट्राई करना है कि यार हो सकता है ऐसी 3 वैल्यूज है जिनका एडिशन टारगेट के इक्वल आ जाए। तो हम क्या कर रहे हैं 1 2 और 3 के साथ चेक कर रहे हैं कि यार 3 के साथ क्या बन सकता है, क्या 4 के साथ बन सकता है। इसी तरह से यहाँ पे क्या 3 के साथ 4 मिला सकते हैं या 4 के साथ कुछ और मिला सकते हैं। इस तरह से हम सारे के सारे कॉम्बिनेशन ट्राई कर रहे हैं इसमें। इज इट क्लियर टू एवरीवन? यस सर, ओके। चलो, पर अब हम इसका कोड कैसे लिखेंगे? क्योंकि लेंथ तो एरे की लेंथ तो कुछ भी हो सकती है। अभी यहाँ पे 4 है, सपोज करो अगर मैं यहाँ पे 5 ऐड कर दूं तो और भी पेयर्स निकल सकते हैं। कैसे? यहाँ पे 5 ऐड हो सकता है, यहाँ पे भी 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 5 ऐड हो सकता है और यहाँ पे भी 5 ऐड हो सकता है। तो हम इस ट्री का कोड कैसे लिखेंगे जो हमने ये ट्री बनाया है, जिसमें हम सारी चीजें ट्राई कर रहे हैं? डू यू गाइज नो व्हाट इज रिकर्जन? You must have read it while you were reading the programming languages. रिकर्जन का क्या मतलब होता है? Yes, sir. Calling a statement inside from a function. Yes, we can say that. Anyone else? So recursion is something where you call the same function again and again. For example, the hello. So you are calling hello from hello inside. Let me show you how. Let's write a simple recursion function. Okay. So let's say we are writing a function called hello. We are passing the value called n, and it returns what? Let's say hello n minus 1 plus hello n minus 2. And we are saying if n is equivalent to 0 or n is equivalent to 1, then return what? 1. Can you guys tell me what will be the output of this function if I call this with a value of, let's say, 5? What will be the output of this function if we call it with hello 5? If I provide the value n as a 5. We are given this function called hello, which always return integer. If n is equivalent to 0 or 1, it always return 1. Otherwise, it returns this. As you guys said that what is recursion function? So it's like calling function from the same function. So we have defined this function, and the statement of the same function is calling the same function again. I mean, it's calling itself. When the function is calling itself, it is called recursion basically. But there, the only thing which will get changed there in the arguments. The values of the arguments always get changed. Otherwise, all the things remain same. So what will be the output of this one? If I say I'm calling this hello function with a value of n, what will be the output of this function? Okay, no one knows that. Let's see. So in first iteration, when this hello will be called, the value of n will be what? 5. Then line number 7 will be executed. Is n equivalent to 0 or 1? No. Then nothing will happen. Nothing will happen here. Next, line number 8. At line number 8, we are doing what? We are returning the sum of hello n minus 1 plus hello n minus 2. So what is hello n minus 1? It is what? It is 4. Since the value of n is 5, the hello will be this one, and it will be what? 3. Now here what will happen? A recursion call will happen. Hello is calling itself hello. So hello will be called again. This time it would be a second iteration. Now value of n would be what? 4 for this one. For this one. Now again line number 7 will be executed first. Again nothing will happen. At line number 8, again we are returning what? The sum of two things, which is what? Hello 3 plus hello 2. Again we got two function recursive calls. So let me show you how it is actually working here. Let me show you a figure how it is getting expanded. We call this function hello. With 5, it called two functions. Hello 4 and hello 3. Then we started working on this one. Okay, this again called two functions. Hello 3, hello 2. Again, this also called two functions. Hello 2, hello 1. Now here what will happen is this one. See why this is not expanding more. Why this hello 1 will not be expanding? Because if you remember the code line, it says if n is equivalent to 0 or 1, it will return 1. So this line is going to return what? 1. Let me write it separately. Hello 1 is what? Returning the 1. That's why this is not expanding anymore. But this hello 2 will expand more, which is what? This hello 1, hello 0. Now again, these two will also not expand anymore because you know if n is equivalent to 0 or 1, they are directly returning the value or the return. Now let's come here. This will also spend. Hello 1 and hello 0. Again, this will not expand anymore because as you know, if a value of n is equivalent to 0 or 1, we are just directly returning the value. We are not calling the function anymore. For this one, again, we will do the same thing. Hello 2, hello 1, hello 1, and then hello 0. This is how that entire operation is going to get executed. By the way, this is what we also call the Fibonacci series. In Fibonacci series, we merge the last two values together. Are you getting what we are trying to do here? Indu, Omkar, are you guys getting what we are doing?
Yes, sir.
Okay, 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 great. So now let's try to see this code again. So can you tell me now what will be the output of this one if we are calling n as a 5 initially? Take your time, take 2-3 minutes, and tell me what will be the output of this hello function if we call with value n as a 5. We are calling this hello function here. I'm giving you 3 minutes. Tell me the answer, like, or tell me what issues are you are facing while you are trying to calculate the answer. Okay, so Omkar said five, sorry, eight. So how is it eight? Yeah, Omkar. So how you calculated that the answer is going to be eight?
First, hello 0 returns 1. Then hello 1 returns 1.
Mhm.
Then hello 2 returns 1 and 0. Then 3
Hello two
returns
returns one and zero. Okay.
then 3 returns 2 and 1.
Okay.
So 2 returns means 1 plus 1, 2, and 3 returns 2, 1, so which equals to 1, 2 plus 1, 3, and the 4 returns 3 and 2, so 3 plus 2, 5, and then 5 returns 4 and 3, so which equals 5 plus 3 is equal to 8.
Okay, let's see the way to calculate it more easier. So yes, so as he mentioned, this will return what? 1. This will return what? 1, because as I mentioned in the code here, what is 1 plus 1? 2.
2,
This will return what? 1. What is 2 plus 1?
3,
3. Okay. This is also 1. This is also 1. 1 plus 1 is what? 2. What is 3 plus 2? 5.
5. Yes.
Let's come here again. 1 and 1 again. 1 plus 1 is 2. This is also what? 1. 2 plus 1 is what? 3. And 5 plus 3 is what? 8.
8.
Is it clear to you how we got the answer, Indu? You also? Okay. Now, if this is clear, let me write another code. Let me know if you are able to understand the code or not first. Is this code clear? Like how it is working, what it is trying to do? So we will call this function as like something like this. Yeah. So is this code clear to everyone? So please provide all the Java code. Yeah, sure. Let me add the Java code also. So here is the Java code. Is it fine now? Now see if you guys are able to understand this code or not. Omkar and Indu, is this code clear to you guys? Okay, okay. So here, let's start with the Java code so that you guys understand it. So here what we are trying to do is this is a combination function which is trying to fetch whether there is a combination exist or not whose sum is equal to the given target. That's it. We are calling this function with this combination 1 comma 2 comma 3 comma 4 comma 0 comma 5. Let me copy it and let's throw it here. And let's have the code also. Okay, now let's see what is going on actually. So when this function is getting called first time with these parameters, after 0 there is something called, let's say, 5. Hold on. First we are checking whether if target is equivalent to 0 or not. But right now target is 5. Let's start with the simple thing. First iteration, again the same thing, first iteration. In first iteration, target is equivalent to 5. Index is what equivalent to? Index is equivalent to 0. And array is as it is. Okay. Now here, if you see this line here, we are calling this function called combination with doing this target minus array dot get one. We are doing something like this: target minus array I. We are looking to find out a combination whose sum is equivalent to the given target, which is 5. So there can be two ways of doing that thing. Either you say, hey, 1 plus 2 plus 2 is equivalent to 5, or you can say, hey, 5 minus 2, then minus 2, and minus 1 is equivalent to 0. And if the target become equivalent to 0, we found out the target. So instead of adding the number and then comparing it with the target, we are just subtracting the number from the target. But we are trying to do the same thing exactly. Find out the combination whether if it exists or not, in such a way that their sum is equivalent to the given target. There can be two ways of doing that. Either you create a separate variable which is called sum. You keep adding the values here, and then you add then check if sum is equal to the target or not. Or you can just subtract the values from target itself and check If it has become equivalent to 0, that means we have found out the target. So this is what we are doing. This is why we are doing this target minus array dot get I. Okay, everything is clear till now? So this part is clear why we are using the target minus this. Yes, no. Okay, what about Indu? Okay. Now let's do the tree for this. Now we are going to draw the tree for this. Let's see how actually the execution is looking like. Okay. So in first iteration, we are starting with this index I. Initially, the target is what? 5 only. Then, for in first iteration, when I was equivalent to what? 0. This line got executed. I became 1, and then target became what? 5 minus 1, which is what? 4. Now this recursion call will again happen. This time I is equivalent to what? 1. Okay. We are again reaching here. We will again do the decrement. What is at I equivalent to 1? It is 2. So what is 4 minus 2? It is 2. Now I has become what? 2. Now there will be again a recursive call. This time I is what? 2. What is at 2? It is 3. What is 2 minus 3? It is negative 1. Is this equivalent to 0? No. So that's how we are finding out the combination. Let's try to do more things. Let's say here we did I equivalent to 1. If you see, this is a for loop. So once this loop ends, once this recursive call get returned, we are going to do the next iteration of that, and there I will be equivalent to what? 2. What is 2 here? It is 3. What is 4 minus 3? It is 1. Again, we are going to do the same operations. Are you getting this now? How it is working? It is actually working the same way that Fibonacci was working, that hello function was working. So the way this backtracking and recursion works is, hey, this function is calling a function, let's go there. This function is calling another function, let's go there. This function is calling another function, let's go there. At a point when they return something, any literal, that like 1 and 0, this loop gets backtracked. Backtrack means here. Go back here. That means this line gets over and it ran into the next line. That means now loop will continue. Once this loop will continue, instead of I equivalent to 1, we will run I equivalent to 2 now at the same iteration. So we came here. Now this also returned something, so we went back. Again, the same loop will continue where I was equivalent to 0. This time I will become 1. And again, this loop will keep getting started this way. I know this is going to be a little bit hard initially, but don't worry, we are going to do multiple questions. At least next 3 sessions would be based on the recursion only. because this is going to be the major part of other trees problem and graph problem also. Have you got the idea how it is actually working? Okay, okay, great. Great. Now, just solve the same problem like you did last time. Tell me what will be the output of this function. Tell me what will be the output of line number 51. Code is from 31 to 49, and tell me what will be the output of this 51 line. I'm giving you 3 4 minutes. Yeah. So have you guys got the answer? Let me check the chat. Okay. So Indu mentioned no problem, Indu. It will take some time, but it's fine. Hopefully you were able to understand whatever I've explained about the trees, how it is working, how the code is generating the combinations and all those things. That was more important. You will session by session you will get the idea how to find all these things. Omkar, um, do you have the answer? No. Okay. Consider this as your homework that you'll have to find out what should be the output of this. You can use chat GPT, whatever you want to use. Just use it and let me know by the tomorrow session that what should be the answer for this question. Okay. In the meantime, let's try to do another question. So you guys definitely know about the chess. Like you must have played a chess game. Yeah, Umka, we are going to we will discuss about the answer for this question tomorrow. Let's discuss one more question today, which is going to be much more easier. So do you know you must have played the chess game. There is a queen there basically in a chess game, and you guys all know the moves of the queen and all that thing. Now we are given a chessboard. We are given what chessboard. Let's say the chessboard is of only four sides. Let's keep it simple. Now you need to place four coins in chessboard in such a way that cannot kill you. How we can do that? This is a chessboard, and we are given four coins. We need to place those four coins in such a way that they cannot kill each other. How we can do it? So consider this that you have a chessboard in your home and someone asks you to do this. So how you are going to do this? There should be some winner. There should be some steps which you will follow. Either you can say, hey, what I will do is, right. So what I will do is I will first try to place a queen here and then check where I can place the second coin. Can I place it here? 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 Let's see. If we place the queen here, don't you think they can kill each other? Yes, they can. So that means we can't place the queen here. Let's cut it then. Can we place the queen here? No. Again, there is a diagonal thing, and the queen can kill each other in a diagonal format also. So we cannot store there also. Can we store the queen here? I think so. So we can place the second queen here. Let's try to place the third queen now. Where can we place the third queen? Can we place the third queen here? No, this queen can go straight and kill us. Can we place the queen here? This queen can kill us. Can we place the queen here? No, this queen can again kill us. Can we place the queen here? That means we are not able to place the third queen till now. So we need to backtrack. We need to go back. If we are able to play queen correctly, it means we are or we are not placing the second queen correctly. So we will backtrack. We will go back step by step. So now what we will do is cut it, cut it, cut it, cut it. That means we need to change the place of second queen again. Let's try to place the queen at last place. Will this work? Yes. So now these two queens cannot kill each other in one. When I say each other, the only one move basically. They are only allowed to make one move, and they should not be able to kill each other. That's the thing. Now let's place the third queen. Can you queen here? No. Can you place the third queen here? Yes, we can. If we place the third queen here, no other queen can kill each other in just one move. They would require one move. Now we need to place fourth queen. Can we place the fourth queen here? No, we cannot. Can we place the fourth queen here? No, we cannot. Can we place the fourth queen here? No, we cannot. Because this can cut us. Can we place the first queen here? Sorry, fourth queen here? No. That means this is also wrong. This combination will also not work. We will again backtrack and try out other possibilities. Can we place the queen here? No, this queen will kill that. Can we place the queen here? No. That means this combination will not work at all. Okay, let's go to the last queen. There is no other move where we can place this queen. So that means we need to now change the place of first queen again. Let's change the place of first queen. Let's move the queue here. Now where can we place the queen? We cannot place it at first location. We cannot place it at second location. We cannot place it at third location, but we can place it at fourth location. So let's place it. Now where should we place our third queen? We can place it at first location. Yes. We can't place it at second location. We can't place it at third location also, and we can't place it at fourth location. Now let's come to the last queen, which is fourth queen. Where should we place this queen? We cannot place it first one, cannot place it at second one, but we can place it at third one. That's right. Don't you think this is correct? Now, no queen can kill each other in just one move. And that was the motive of this question. Are you getting how we found out this thing? Let me put the charger also. Are you guys getting how we have solved this problem? Yes, no. Yes. What about Indu? Yes, sir. If I ask you to write the code, will you be able to write the code for this? No, sir. Okay. But let's talk about another question in that case. You must know Sudoku. What is Sudoku? What are the rules of Sudoku game? That we need to place numbers from 0 to 9 in such a way that I forgot that rule. What was that rule? Do you guys remember how we used to solve the Sudoku game? Let me open the question itself. Let's try to do this one. Just read out this question once. Done? Have you guys understood the question? No. Okay. So we are given a Sudoku puzzle where each digits basically you need to fill the Sudoku puzzle and the digits we use is only from 1 to 9. And in each row and column there should be no repetition. For example, in one column, if one is already used, then you cannot use another one in the same column or the row. You can use it anywhere else, but same column and same row should not be there, basically. And we need to fill this entire Sudoku with that way. Do you know how we can solve this problem by the same approach which we did with the queen and queen thing? Yes, no, guys. Okay. What if we say that we can solve the same problem with the same way? Like you will try to put the digits at every box one by one, and then you will validate whether the move is correct or not. In N Queen, what we were doing, we were taking two steps. First step was to place the queen. The second step was to validate the board whether hey, like whatever is the current state of the board, we should check whether any queen can kill each other or not. If it is possible that the queen can kill each other, that means we need to go backtrack and try the different position of the queens. We can't move on. Similarly, in this Sudoku problem, we are going to do the same thing. We are going to try out different numbers. For example, this picture is given here. 5 and 3 is already filled. So in third one, this one, we can either fill 1, we can either fill 2, we can either fill 3, we can either fill 4. Whatever digit we filled, after that we try to check out all these checkbox that hey, that digit should not be available in any column at all. That digit should not be in the entire row. There should be only single use of that and all that thing. And if everything is fine, then we move on to the next box, which is this one. Try to place a digit here. Again, check whether the everything is fine or not. If everything is fine, then you move on with the next box. This is how we solve these kind of problem. This is like a brute force approach. Saying कि यार मैं हर बॉक्स पे सारी वैल्यूज ट्राई कर करके देखूंगा और अगर वो चीज सही चल रही है तो मैं आगे वाले बॉक्स पे जाऊंगा फिर वहां पे भी ट्राई करके देखूंगा. So this is how you are going to solve these recursion and backtracking problems normally. Don't worry, it's going to take time to understand recursion and backtracking. At least we are going to have next 3 sessions just based on the recursion and backtracking only. So don't worry about these things. But make sure you are spending enough time on trying to understand the questions, doing try to solve more questions on it code, go through the questions list. Make sure you are done with all the previous patterns which we have so covered, like sliding window, binary search, hashing, two pointers, so linked list. We have covered multiple types of patterns till now. So you guys should be like well good with those patterns. Then only you will be able to move on with these things. Is it clear? Okay. Yeah, so I will take 5 minutes break and after that we will start going through the previous questions. So you guys must have tried some questions and you must if you have any doubt or any concern, so we will try to solve those questions together. Not related to the recursion backtracking, but all the previous topics which we have covered till now, like two pointer, sliding window, and all those things. So we will meet back at 03:38. Okay. Hey, yeah. Yeah, Omkar. So have you done any question from the given list from the previous sessions that which you want to discuss? Hey, Omkar, can you hear me?
Yes, sir.
Yeah. Have you done the questions from the previous list?
Yes, only two or three.
Only two or three. From which one?
Uh, 2 pointers.
What was the question?
Mm, First two sum,
Then,
then I'm unable to solve the third one problem.
which the problem name is what? Just send me the link in the chat. We can try to solve it now. Can you send me the link of the question? We will try to do it together. Let's see like what issues you are facing in that question. Can you tell me the question name? The question, can you a little bit give me the idea? Maybe we can, I can get you the paper. So you are saying it's the third one. Let's go to the course. Course note. You said 2 pointer. Okay, so you mean the foursome? Are you talking about the foursome problem? Trapping water. We have solved the trapping water question in one of the recordings. Have you seen that recording? So there were in I think in the first doubt session we have solved the trapping water. Have you seen that video?
Yes, yes, sir.
So were you not able to understand that?
I know the logic, but I'm not able to write the code.
Okay, okay. Have you tried to go through the discussion code, like what the code which is already there in editorial discussions? Because in the first go, it will be hard to write the code for that. So you would have to first go to the discussion section, try to read the code which is already there, and then try to recode it. Have you tried to do it that way?
No, sir.
Okay, I would suggest you to do it that way once. If that is still not working for you, then maybe we can code the solution in the next session. Then.
Okay.
But at least give it a effort once.
Okay.
Okay. What about linked list? Have you tried any question from the linked list?
No, sir.
Okay. Okay, I think for today I don't have anything else to discuss. Today I just wanted to give you the overview about the recursion and backtracking since it's a like little bit hard topic. So we are going to do more questions tomorrow and in for upcoming 3 sessions. So today I want to keep it light only. Do you have any more questions to ask?
No, sir. But I'm not able to write code on my own. I'm seeing the uh, previous means the code written in YouTube or using. Hello.
For yeah, I can hear you. For which questions you have tried to write the code?
Only two sum or three sum.
So till now you have only write the code for 2 problems.
Yes.
So see, this is not enough. I mean, right? If you want to become better at writing the code, it will take some time.
Oh,
Okay. So I would suggest you start doing more lead code easy questions first.
yes, sir, I'm doing this. Means I saw easy questions on Report, but
Okay.
the questions are you posted on a website. I'm not able to write.
Okay. Okay. Then why don't you like ask those questions during the sessions itself when I ask like what are the doubts and concerns? Because if you would have asked them during that time, it would have been much more easier. Today
Oh,
also like you are joining from mobile, so I can't give you more explanation there. So make sure whatever doubts you are facing when you are solving the question, note it somewhere on the doc or somewhere else at your own side. And in the session, in the beginning of the session, ask those questions. So we can try to fix those things.
okay.
That's the only way to improve.
Okay.
Okay, when you come next time, make sure like you have noted down all of your doubts. What was the issue which you faced while you were trying to write the code, and we can discuss how to move forward with from that way.
Okay.
And I would suggest to start doing the linked list question. They are easier comparison to other.
Okay.
Okay. Anything else you want to discuss?
No, sir.
Okay, then maybe we can wrap up for today. Okay, then bye.
Thank you, sir.
Yeah.